All right, let's dive in. Today, we're looking at industrial and engineering chemistry, but from a very specific angle.
Yeah, we've got access to these lectures from Professor Pushpito Ghosh over at ICT Mumbai.
The Institute of Chemical Technology. That's a pretty big deal.
Yeah, prestigious place. And we've got, think about it this way, 75% of this one course, lectures 1 through 31.
From 2021 to 2022.
Exactly. So we're really getting a feel for what a real undergrad chemie student.
The experience is like.
Exactly. So it's a cool perspective.
Yeah, for sure. And we're not just talking like intro-level stuff here either. We're going deep.
Yeah, real deep. Historical context, innovations.
And what really struck me is Professor Ghosh, he doesn't shy away from real-world stuff.
Oh, yeah.
Like he uses the Bhopal gas tragedy
Oh, right.
to really highlight why inherent safety in these processes is
Absolutely crucial.
so important. Yeah.
Yeah, powerful reminder that we're dealing with powerful stuff here.
Yeah, for sure. And he starts off strong too by really asking why. Why is industrial and engineering chemistry
It's important.
important? What's the point?
What should a chemical engineer be striving for in this field?
Right.
It's a big question. And he doesn't just give a simple answer. He's pushing these students to think about, are they just technicians? Are they problem solvers? Are they innovators?
That's interesting.
Yeah, and more these days.
What?
Stewards of sustainability.
Okay, so it's bigger than just,
Right.
mixing chemicals.
It's not just about knowing the equations.
Right.
He's challenging them to think long term. How do we manage resources, optimize these processes, always be improving, but with
sustainability in mind.
Exactly, the whole package.
That's so cool. He even brings in Fred Talien's book.
A history of the international chemical industry.
Yes, to give that historical context.
Yeah, see how the field's evolved?
Oh, that's a good point.
Not a static thing, it's always changing.
Right.
Adapting,
yeah. So, okay, we got the why, we've got the history. What are some of the actual processes?
Okay, so he starts with a classic sulfuric acid, often called the king of chemicals.
King of chemicals, huh? I'm intrigued by that title.
Because it's vital to so many industries.
Really? Like what?
Fertilizers, batteries, detergents, even explosives.
Wow, that is versatile.
Professor Ghosh says a country's sulfuric acid production, it's almost like a measure of its industrial strength.
Interesting. A chemical barometer.
Exactly. And it's a journey, you start with the chamber process,
Okay.
then move on to that modern contact process.
Yeah, I remember learning about that. All about the catalysts.
Optimizing those reaction conditions.
Yeah.
Exactly. But he doesn't just describe it, he breaks down why it was such a big deal, Efficiency, cutting down on waste.
Making it more sustainable.
Yeah, it is again, yeah.
I'm seeing a theme here.
And he's honest about the challenges, too. Like, as we move away from fossil fuels, where's the sulfuric acid of the future coming from?
What are those alternative feedstocks?
Exactly. Can't rely on the same old forever.
Right.
And speaking of essential chemicals, let's move on to soda ash.
Soda ash. Now, that's something we encounter every day.
It is. Glass, detergents, baking soda, all thanks to soda ash.
And remember that very first U.S. patent we talked about?
The wood ash one.
Yeah. Well, that's where the story of soda ash production begins.
So we're going back to the very beginning.
We are. Samuel Hopkins, the inventor, he figured out a better way to get potash from wood ash.
And potash was crucial back then, right?
Oh, yeah, for soap and glass production.
So his innovation, it sparked a whole chain of events.
It did, leading to more and more sophisticated ways to produce soda ash.
That's amazing. One patent, so much impact.
That's innovation for you.
One of those early processes was the LeBlanc process, revolutionary in its time.
18th century, right.
You got it. But it had its downsides, just like that chamber process for sulfuric acid.
So what replaced it?
The solvate process.
Ah, the one we still use today.
Exactly. More efficient, more environmentally friendly.
What's the key difference?
Well, it uses readily available materials like salt and limestone.
Makes sense.
And speaking of salt, Professor Ghosh emphasizes the importance of salt purification.
Oh, yeah, especially for a country like India.
With that vast coastline, it's ideal for solar salt production.
Sustainable and energy efficient.
Exactly. Plus, there's the dual process, a more efficient version of the solvay process.
Always room for improvement.
It is incredible how they keep refining these processes.
Striving for greater efficiency. That's the name of the game. Okay, so we've got sulfuric acid, soda ash. What else is he diving into?
But let's talk about the chlor-alkali process. Breaking down salt, you get chlorine, caustic soda.
Oh, yeah. I remember reading about how they used to use mercury for that.
Not the best idea, right?
Huge environmental concern.
Exactly. Professor Goetsch talks about that shift, moving away from the mercury cells to membrane technology.
Much cleaner.
Safer, too.
It's interesting how, those environmental concerns actually drove innovation.
Yeah, they forced the industry to find a better way.
That's a good thing. Okay, so what about aluminum production?
Another essential one, he focuses on the Hall-Héroult process. This one was revolutionary.
Right, using electrolysis to get aluminum from its ore.
Yeah, ingenious stuff. But even with a process like that, there are limitations. Professor Goetsch points out it's energy intensive.
Oh, yeah, that is a concern.
Especially as we move towards cleaner energy sources.
It's all about finding that balance, right?
Always. Producing what we need, but minimizing the impact.
Makes sense. So we've got sulfuric acid, soda ash, chlor-alkali, aluminum. What's next?
Get ready for this one. Air separation.
Air separation.
Specifically, the Lind process. They use cryogenics to separate air into its components.
They can turn air into a liquid.
It's wild. They cool it down to extremely low temperatures.
Wow.
Different components liquefy at different points, and boom, separation.
And then you've got all these useful gases, right?
Oxygen for medical and industrial uses, nitrogen for food preservation and fertilizers, argon goes into lighting, welding.
Wow. I never thought about air being so valuable.
It's all around us, but it takes understanding those properties, manipulating them.
That make them useful.
Exactly. That's chemical engineering in a nutshell.
So all this talk about industrial processes, it makes me think about the impact on something we can't live without.
What's that?
Water. Does Professor Goetsch talk about that at all?
He does. In fact, water management is a big focus in these lectures. He really emphasizes how crucial it is for the chemical industry.
Let's dive into that. This is already mind-blowing.
Okay, buckle up. Professor Goetsch makes it clear. Water's not just some side thing, it's a vital resource.
Yeah, I mean, we use it for cooling, for cleaning, even in reactions themselves.
Right. And then there's the whole issue of scarcity.
Oh, right. Not enough to go around.
He introduces this idea of a water footprint.
Water footprint, what's that?
Think of it like this. How much water goes into making a product? Not just what you see, but everything, from start to finish.
Oh, interesting. The hidden water, like in the raw materials.
Yeah, exactly. Makes you think about the bigger picture, right? And then he dives into water treatment, desalination.
Reverse osmosis, things like that. I've heard that's getting pretty big.
It is. He explains how RO works. You've got a membrane, filters out impurities.
Yeah.
But he also talks about newer stuff, forward osmosis.
Okay.
Different type of membrane, uses a draw solution. It's pretty cool.
Sounds like a lot of innovation happening there.
Definitely. And it's not just clean drinking water either.
Right.
Wastewater treatment is huge. He talks about how to measure water quality, BOD, and COD.
Hold on. Break those down for me. BOD and COD.
Imagine wastewater, right, like a big pot of it. BOD tells you how much oxygen bacteria need to break down the organic stuff. It's like how much food is there for the bacteria.
So high BOD, that's bad.
Lots of pollution, yeah. CSAID is similar, but it measures all the oxygen needed to break down everything, whether bacteria can handle it or not.
So it's like the total food in the pot.
Exactly. You measure these, you know how polluted the water is, how well your treatment's working?
Makes sense. You got to make sure the water's clean before it goes back out.
Professor Goetsch really stresses that. Protect the environment, meet those standards.
It's amazing how much goes into water management. It seems so basic, but it's not.
Right. Speaking of complex, let's talk about fertilizers.
Oh, yeah. Essential stuff. Feeding the world. I remember learning about the Haber-Bosch process.
He talks about that, but he goes back even further to the pre-Haber days. Stuff like calcium cyanamide production.
Really?
Ingenious, but they just couldn't keep up with the demand.
And then Haber-Bosch changed everything.
High pressure, high temperature, ammonia on a massive scale, air, natural gas, that's all you need.
It's incredible how that one molecule, ammonia, has had such a huge impact.
It has. But he points out there's always room to do better. So he goes into the Ostwald process.
Nitric acid.
Yep. Uses ammonia as a starting material.
It's all connected.
One process leads to the next. But he's not ignoring the environmental side either. NOx abatement. Got to reduce those harmful emissions.
Yeah, got to find that balance again.
Production and responsibility.
Right. So we've got nitrogen fertilizers. What about the other types?
He covers phosphates, too. Phosphoric acid production, all the challenges with removing impurities.
Interesting. It's making me look at fertilizer in a whole new way.
And then there's potash, mined from natural deposits different extraction methods, all with their own quirks.
Wow, so much complexity behind something we just sprinkle on our plants.
It is fascinating. But, as we move towards a more sustainable future, it's not just about producing more.
We
It's about producing smarter. And that's where bioprocesses come in.
Oh, yeah, bioprocesses. This is where things get really futuristic.
Harnessing the power of nature. Less waste, renewable resources.
More sustainable industrial chemistry.
You got it. He starts with bioethanol.
Yeah.
Versatile stuff. Fuel. Feedstock.
I've heard about blending it with gasoline.
That's one use. But he brings up the food versus fuel debate, too.
Oh, right. Using food crops to make fuel, that's a tough one.
Ethical considerations, social impacts. Professor Ghosh gets into all that. And then there's biodiesel.
So many different ways to make biofuels.
From vegetable oils to animal fats.
Yeah.
And researchers are always innovating, finding new catalysts, better reaction conditions, even using waste materials like used cooking oil.
Wow, so much potential there.
There is. And then he introduces biocatalysis.
Bio what?
Biocatalysis, using enzymes to speed up reactions.
So instead of harsh chemicals and high temperatures.
You've got these natural catalysts doing the work. More efficient, more controlled.
Clever.
He gives examples of how they're scaling up these biocatalytic processes, pharmaceuticals, food production, all sorts of things.
Amazing. But aren't there challenges with scaling those up?
Of course. Finding enzymes that are tough enough to withstand industrial conditions, optimizing those reaction conditions, and figuring out efficient ways to separate and purify the products. That's all part of the puzzle.
Sounds like there's still a lot to learn.
Definitely. But his lectures really highlight the excitement, the potential of this field. Bioprocesses are like a new frontier in industrial chemistry.
More sustainable, more responsible.
Exactly. But while bioprocesses are definitely the future, right now the industry still relies heavily on oil and gas. So he brings in Dr. D. Parvadalu, an expert in oil and gas.
A guest lecturer. That's cool. What does he talk about?
Dr. Parvadalu dives into the upstream side of things. Exploration, field development, production.
So like how we find the oil and gas, extract it, all that.
The whole process, from the geology to the engineering challenges, even talks about the environmental considerations.
It's fascinating to get that perspective. But what about after we've got the oil and gas? What happens then?
That's where Professor Ghosh takes over again. Petrochemicals.
Right. Petrochemicals are in everything these days.
They are. Plastics, fibers, detergents, even fertilizers. Professor Ghosh explains how we get these valuable chemicals from oil and gas.
So it's like a whole other world of chemistry.
He walks through a typical petrochemical refinery, explaining how they separate crude oil into different fractions and then process those into all sorts of chemicals.
Sounds complicated.
It is. But he breaks down key transformations like methane to syngas, that's carbon monoxide and hydrogen, used for making other things like methanol.
Oh, wow.
And then there's naphtha cracking to produce ethylene, essential for making plastics.
It's like a giant chemical puzzle.
It really is. And
Yeah.
Professor Ghosh does an amazing job of explaining it all, highlighting the reactions, the engineering principles.
So we've gone from sulfuric acid to petrochemicals. Is there anything else on his syllabus?
One more thing. As we move towards a more sustainable future, energy storage is key. So he wraps things up with a technology that's getting a lot of attention these days.
Batteries.
Batteries, specifically lithium-ion batteries. He traces the evolution of batteries, starting with the old lead-acid kind, then moving on to secondary batteries, the rechargeable ones.
I mean, we use them for everything now. Phones, laptops, even cars.
Right. So he really focuses on lithium-ion batteries, explains how they work, the advantages, the ongoing research to improve them.
They're constantly making them better. More energy density, longer lifespan.
Exactly. But he doesn't just present the tech. He also encourages his students to think critically about the challenges, like where do those raw materials come from? What about the environmental impact when we dispose of them?
It's about thinking ahead, the whole life cycle.
Professor Ghosh's lectures, they really give a comprehensive overview of the chemical industry, from the basics to the cutting edge. It's a lot to take in.
It is. But what really stands out to you? What are some of the key takeaways?
Honestly, the sheer scope is what gets me. He's covering everything. Like, he's giving these students a blueprint for the entire chemical industry.
Yeah, from the fundamental stuff to the latest tech.
And through it all, that emphasis on sustainability. It's not just a side note, it's like the core.
Yeah, he's really pushing them to think about the environmental impact, to find those alternatives.
It's more than just pollution, though. It's about managing those resources, being efficient with energy, designing processes from the ground up with the planet in mind.
I was really impressed with that section on bioprocesses.
Hmm.
It feels like a whole new way of doing things.
It is. And it's still so new, so much potential to grow.
It makes you wonder, like, what are the biggest challenges for the industry to really become sustainable?
I think a big one is just the scale of things. We've got so much infrastructure built around those old processes, fossil fuels, lots of waste.
It's not easy to just change overnight.
Exactly. It
Is
takes
it?
investment and it takes changing how we think about things.
And then there's the technology itself, right? It's got to be sustainable, but it's also got to be practical.
Yeah, it can't just be good for the environment. It's got to work in the real world.
That's something Professor Ghosh really highlighted. He's not shying away from the economic side of things.
Right. It's got to make sense. But he's also encouraging those students to think outside the box, to push the boundaries.
Find those innovative solutions.
That balance is key, I think. Acknowledging the difficulties, but not losing that sense of optimism.
You know, something else that really struck me was how much he emphasized safety.
The Bhopal gas tragedy. That's a powerful reminder.
Yeah, and he makes it clear safety is not optional.
Designing those processes with safety in mind from the start. And even better, inherent safety.
Where the process itself is inherently safer.
Right. No matter what, you're reducing the risk.
It's clear he takes that responsibility seriously.
Which is how it should be. We're talking about processes that can have a huge impact, on people, on the planet.
So, as we wrap up this deep dive, what are some key takeaways for our listeners, even if they're not, chemie students?
I think the biggest one is the chemical industry. It's all around us. It's in the products we use, the technology we rely on.
It's easy to forget about, but it's there, working behind the scenes.
And it's changing. That push towards sustainability, it's real. New technologies, renewable resources, rethinking those old processes.
It's a good reminder that things can change, that progress is possible.
And Professor Ghosh, he's part of that. He's educating, he's inspiring the next generation.
To lead that change.
His lectures, they show how powerful education can be. Not just learning facts, but changing how we see things, sparking new ideas.
Well, I'm feeling pretty inspired right now. It's given me a whole new appreciation for what the chemical industry does and for the people working to make it better.
I agree. It's a field full of challenges, but full of opportunity too. And the future, it belongs to those who are innovative, who are committed to sustainability, to doing things the right way.
So to everyone listening, whether you're a chemist or just curious about the world, remember, chemistry is everywhere. It's the air we breathe, the water we drink, the things we use.
And like we've learned from Professor Ghosh, understanding those principles, those processes, it's key to making smart decisions, to building a better future for all of us.
Great point to end on. Thanks for joining us for this deep dive into industrial and engineering chemistry. Until next time, stay curious.